Hey, Waf.
Hey, Kay Flan, what are we chatting about today?
So today we're going to talk about experimental design.
Tell me more.
Experimental design is one of my favorite topics in data science because I think it's really important to understand how data is collected before we actually start analyzing it. So with experimental design, what I mean when I say that is just how do we design experiments? And we're going to think of designing an experiment from the point of view of a researcher.
So do you actually design experiments? You don't just ask random questions?
Yeah, so it's good to think about what exactly you're going to do in order to test something out. So with experimental design, we often want to know, does something work? So I'm going to think about this in the context of an example. So let's say, Wade, that we have a drug that we think will help students learn data science.
Okay, so we should give it to everyone because it's going to help them learn data science.
Yeah, so that's our hypothesis, but we don't know if it actually works. So before we give it to everyone, what we're going to do is actually do an experiment to see if something works.
How do we do that?
So let's say that we have 100 volunteers. So I'm going to assume that we have 100 students who are very excited about this new drug. So we have 100 participants.
So they all want to take this drug. They're all hyped to have it.
Yes, and we think it'll help them learn data science, but we're not sure. So the best way to actually test this out is to go ahead and divide the subjects into two groups, a group of people who get the drug and a group of people who don't. So then at the end of the study, we can actually compare the people who got the drug to actual data from people who didn't.
Do we call these groups certain things?
Yeah, so the first group we call the treatment group. And the treatment group is the group that gets whatever you're trying to test. So in our case, they are getting the drug. And then the other group we actually call the control group. And the word control is used a lot in statistics. Here, the control group is basically just a comparison group that we collect data on. And they don't get a drug, so they get no drug. And oftentimes, we don't want people to know who's in which group. So we'll give the control group something called a placebo to make it so that they don't actually know. They're still taking something, so they don't actually know if they're in the treatment or control group. So I'm going to say no drug or a placebo. And there's many different ways that we can do this. So there's a lot of ways that we can divide subjects into a treatment and control group. But the goal in any experimental design, and I'm actually going to write this down because of how important it is. The main goal in experimental design is to have the treatment and control groups be as alike as possible. And the reason that we want this to be the case is because at the beginning of the study, if our groups are as alike as possible, then at the end of the study, if we see an improvement in the treatment group, we know that that's from the treatment and not something else.
Ooh, okay. So is there different criteria that we look at a study? Because I've got studies we can look at if you want to dive into some studies.
Yeah. Before we do that, I just want to say really quickly what the ideal experimental design is, because there's a lot of ways that we could do this. We could have the researchers kind of pick who's in which group. We could have the subjects themselves decide who's in each group. But if we don't use a random method for selecting who's in the treatment and control group, oftentimes those groups are going to be different. Because if I told the participants, oh, you can just pick which group you're going to be in, people who pick the treatment group might be different who pick the control group.
Yeah, I definitely want to take the drug, so I'm going to definitely be in the treatment group.
Yeah, and maybe you're worried about the class, maybe you don't think you're that good at data science, so that's why you're picking the treatment group. So the best way to design an experiment, the gold standard, is something called a randomized, controlled, double-blind experiment. And sometimes you'll see these called randomized controlled trials or RCTs. There's a lot of ways to kind of say this, but the key idea is that the experiment has three things. One is that it's randomized. So basically what that means is that the people are divided into the treatment and control group randomly. And back in the day, they used to do this by literally flipping a coin. Now, Wade, I think you've done this a lot. We're using Python, right?
Yeah, I've had some researchers come to me and ask me to divide their research participants in half using a random selection, and also removing the names from it so the researcher doesn't even know who's involved in the study.
Yes, and that's actually part of the double-blind part of this study. So randomize is best. because random assignment is the most likely to make these groups as alike as possible. We also want to make sure it's controlled. We want to make sure there is a control group that we're comparing to people who are actually not taking the drug, so we have data on that. And then what you mentioned is about this double blind part. So double blind basically means that the researchers and the participants in the study don't know who's in each group because we don't want any bias of that knowledge. So Wade, you said that as a computer scientist, sometimes you'll be the person that's dividing subjects into the group because we don't want the researcher to know.
Yeah, they'll actually have me create like a Google form. I'll collect all the results, and then I will randomize who's in the treatment group, who's in group A, and who's in group B. And I won't even know if it's a treatment or control group. I'll just assign it A or B, and then give them numbers so that the researcher has no clue who is the actual person in group A or who the actual person in group B. They just know participant number 2, 7, and 14 are in group A, for example.
Exactly. So again, our key idea is we want those groups to be as alike as possible. We want to minimize selection bias. We want to minimize subject bias. We don't want the participants to be biased. We don't want the researchers to be biased. So if we have this randomized controlled double-blind experiment, the nice thing is that ensures our groups are balanced at the start of the study, and at the end of the study, we can trust the results, which is the key idea. So you said you had some examples of studies, so I think it's a good time to look at those.
Yeah, is every study always going to follow these RCT standards?
Ooh, so I wish that was the case, but sometimes we can't have a randomized controlled double-blind experiment. Sometimes there's actually studies that we're doing where it would be unethical to assign people to a treatment group. So in that case, we call the studies observational studies, which is where we just observe something that happens. People naturally tend to be in a treatment group or a control group. And that's okay. We're going to talk about how we can manage observational studies in discovery. But if we can do a randomized controlled experiment, it is definitely ideal. It is expensive. It is a lot. There are some cons to this. It's definitely more complicated. Oftentimes you have to have a third-party person doing the random assignment, but the benefits are amazing.
So when I took my cat to the vet most recently, she's getting old, she's like 15, and we're worried about arthritis, and there's a new drug that was recently approved to treat arthritis in cats. And I looked at the drug's clinical trial and found this research paper, and it has this great methods section at the top that really seems to describe how the study was done.
Ooh, I really like that. And with any research paper or article that you're reading, it's good to look at how was the experimental design, because then that can help you in deciding, do I want to trust these results? They give some background, they give the objective, they tell us the animals or the participants in this case. And with the methods, I see right here that it says this was a randomized, placebo-controlled, parallel group, double-blind superiority study. So that is very, very specific. But right away, I see those 3 words that I was looking for: randomized, controlled, and double-blind. So this looks like it was an amazing study. They randomly divided the cats into 2 groups. They gave some of them the drug and some of them the placebo. And the results, if we look at the results, it says that significant improvement with the drug over the placebo occurred at days 28 and 56 for the outcomes that they were measuring. So if I was looking at this study, just looking at the overview, I would say they did a good experimental design. So if they concluded that the drug seems like it works, that's what I would trust.
Okay, so this seems like a gold standard of a study, something I could really trust.
This one looks great.
I have a second study that looked at the lifestyle behavior and health outcomes of UK university students.
Oh, okay, so university students.
And I like this study because it also had a methods section right at the top, so we could really dive into it right away.
Yes, this looks great. They have the background kind of about the study and about the students. And then the methods, it says it was an online self-report survey. It was administered across 3 years to university students, and then it talks about the analysis that they did. And while this is interesting, online surveys are great. This is definitely going to be more of that observational study because the students are deciding, do they want to do this survey or not? The researcher isn't randomly dividing them. So if they're trying to see does something work or looking for a specific outcome, I would definitely want to make sure that they did some analysis at the end to take into account that this wasn't a randomized controlled double-blind experiment.
So from what I hear, there may be more bias in these results that may not be intentional, but may just come in through which students end up choosing to enroll in the survey and whatnot?
Exactly, and that doesn't necessarily mean it's bad, it just means we need to take that into account. So that's kind of a brief overview of experimental design, and we're going to dive way more into this throughout the Discovery course.
So, and that is experimental design.